All right, my name is Mike Phillips. I'm going to be teaching the module on cardiovascular training. It's module 3B from the IAFF Pure Fitness Trainer modules. With this, it's actually a 75-minute module, and I've been given 15 minutes to do this. So I'm going to be kind of picking my key points out of it that I think are the most important to focus on. We're going to start at slide 13 actually and move through the intensity portion of the FIT principles, which is kind of the main focus of what we're going to be covering throughout this. That's where it gets the most abstract. That's where we cover the majority of the calculations and things as far as how to determine intensity for our people that we're training. So that's where I'm going to spend the majority of my time. In a classroom environment, when we're working with individual people, anytime we do anything fitness related, we're going to be trying to find time to warm up. We're firefighters. If we get woke up at 3 in the morning, there isn't time to warm up. We got to be able to react quickly. But in a training environment, we need to take the time to warm up because it does a multitude of things. Obviously, we're going to be able to kind of rev up that cardiovascular system ahead of time. We're able to increase the blood flow to the muscles and just try to get people's body temperatures up. Our recommendations typically, like here, 5 to 10 minutes progressive aerobic activity and sufficient enough to reach the lower limit of our training. We'll cover what those cardio limits are, what the actual physiological limits are for heart rate in a later slide. We also want to work to get 5 to 10 minutes of low intensity calisthenic stretching. So just as an example, if our cardio workout is going to be running on a treadmill for a person. An ideal warm-up would be 5 to 10 minutes of a slower pace walking on that treadmill, kind of just getting the blood flowing, getting the people to the point where they're warmed up. We want to get that little bit of sweat going, but we don't want to get to the point where we're fatiguing these people before they even start the workout. Another example of calisthenics, if our workout's going to be putting our fire gear on and going out and doing firefighter evolutions, we need to have a little bit more of a more ramped up warm-up. Maybe we do some jumping jacks, maybe we do some calisthenics like some push-ups and some mountain climbers, things to kind of get more of that system going to prepare them for the work at hand. Goes along with warm-up, obviously is going to be our cool down as well. All right. In a perfect world, we always have time to do cool downs. Once again, a lot of these workouts we're doing with people are going to be on the clock, we're going to be at work, and sometimes we catch runs and have to be able to move through it. But what we're going to focus on is the key and the importance of doing a cool down with our people. Typically with cool downs, this is going to cover each thing. It's going to reduce potential for hypertension, enhance venous return. All these things are important because our goal with our people is to be able to promote recovery. Okay? One of the keys to cooling down, it allows this system that we've actually ramped up from a pre-exercise up to this intense workout, we have to give it a way to kind of recover. So by doing this, by going back through those motions and, say I mentioned working on a elliptical machine. If we take at the end of the workout and we just slow down and kind of do those same motions but just at a lower pace, lower stress level, it actually allows these systems to continue to work and flush that blood out. Because ultimately when we're doing this hard workout, our heart's pumping extra hard, it's got heavily oxygenated blood, lots of nutrients, all those things are getting flushed out into those muscles to help recover from those little micro tears and things that are happening on a cellular level. What we're actually doing is allowing that blood to keep flowing, because if we stop immediately at the end of a workout, that rich oxygenated blood no longer is flowing into those muscles, okay? The lactic acid and all those byproducts are still sitting there and there's no way for them to get out. So the key to a good warm-up, it's going to obviously do several of these things. The hypotension enhances that venous return because the muscles actually working are helping to kind of shunt that blood back to the heart to get worked through. Helps dissipate the body heat, gives us an actual time to really cool down. And like I mentioned before with the removal of lactic acid, anytime you've got someone that's actually deconditioned to some extent, hasn't really been working out a lot, that first time working out, they're going to feel it. They're going to have that lactic acid build up and they're going to get that muscle soreness. Me personally, I love feeling a little bit sore the day after working out because I know I've accomplished something. But with a brand new person that's not really used to that level of soreness, this could kind of scare them away. So you're actually setting your people up for success by taking the time to do this cool down and really help them by physically flushing that lactic acid back out of the system. Other things, as it says here, reduce risk of arrhythmias, and I kind of touched on this, prevents blood pooling, reduces risk of fainting. Okay, so ultimately, by allowing them this time to kind of go from this intense workout portion and then being able to drop back down into their pre-workout phase that they were at the beginning. Next slide is actually our frequency. This gets into the bulk of what our FIT principle is. We're dealing with frequency, intensity, time, and type. These are the 4 things that we will actually work with as trainers with our people. Frequency is pretty straightforward. I need you to work out, cardio 3 days a week, and we're going to lift weights twice a week, whatever that is. Obviously, based on what that person's goals are, that will determine what our frequency is. The thing that I'm really going to spend the majority of my time with is this next slide, which is intensity. Intensity is the one thing that's a little more abstract, and in my opinion, it really is the most important of the 3 slides. Because in these next 3 slides, I'm actually going to show you ways that we are able to quantify intensity on multiple different levels. So ultimately with this, by us adjusting intensity and using these formulas I'm going to go over here in a minute on the whiteboard, we'll actually be able to show people how to get results. All right, so our first one, maximum heart rate. According to this is our target heart rate. We're going to take 220 minus our age, and then our percentages is 55 at the lower end and 90% at the upper end. This is the range we want our people to be working out in due to this formula. Back one. As it says here, does not match VO2 as well as the Karvonen method. The Karvonen method will be the next slide. It actually does a little bit more where it brings into account resting heart rate as well. So it's much more accurate if you use a true max heart rate. In this predicted formula, we're basically just taking what their max heart rate is, which in the predicted formula is 220 minus age, which I just said. So it is specific for different exercise models. So now I'll go to the whiteboard and show you how we break that down for just a typical 20-year-old person. All right, so our scenario that I've drawn up, maximum heart rate, we're going to try to figure out what the target heart rate would be for this person. We're just going to assume it's a 20-year-old person for easy math. So 220 minus 20 gives us 200. And we're going to multiply that by our range, okay? 55% is going to be the low end, and 90% is going to be our high end. So 200 times 0.55 puts us at 110. 200 times 0.9 is going to put us at 180. Okay, so our estimated target heart rate range using this formula is going to be between 110 and 180. All right, now we'll move into the Karvonen method. All right, the Karvonen formula. This formula, once again, just like the max heart rate, this one is a physiological test. This is actually looking at our heart and how fast it's beating. So with the Karvonen method, you're actually taking your max heart rate minus your resting heart rate. In the example I'm going to give, it's a 20-year-old person that has a 60 beats per minute resting heart rate. So you're basically taking that max minus their resting, multiply it times their intensity, which in this formula is 40 to 85% of the max heart rate, plus the heart rate at rest. Okay? What this does differently than the max heart rate is that it accounts for the resting heart rate, and it does actually match better with the VO2. Ultimately, when I do these 2 numbers for a 20-year-old person and I break it down, you're going to see the numbers are really very similar. This is just a little bit more accurate as far as matching what VO2 will be. And I'll show that on the whiteboard here. All right, so here's our Karvonen's formula. Heart rate max minus heart rate rest times your intensity, and then you add back in the heart rate rest at the end. Okay, so once again, we're saying a 20-year-old. So 220 minus 20 is going to give us our heart rate max, which is going to be 200, minus our resting heart rate. We're going to assume that this person's resting heart rate is 60 beats per minute. Best way to do this is just have your clients, as they come in, say, okay, I need you to check your resting heart rate every morning first thing when you wake up. While you're still laying in bed, just check your pulse, see where you're at. 60 is a nice, easy number. Once again, I'm just trying to simplify my math up here on the board. So 200 minus 60 times your intensity, whether that's 0.40 or 0.85, and then you're going to add back in that resting heart rate again. Okay, so here you got 140, that's what that breaks down to. So you do your math, end up with 116, and the max rate at this is 179. So the range using Karvonen method is going to be 116 to 179, and if I remember right, using the max heart rate, it was 110 and 180, I believe. So as you can tell, the numbers we're getting with Karvonen are more closely related to the VO2 max, but they end up being pretty similar to what we'd get from the first formula. All right, so now we're going to move from obviously the physiological tests, and we're going to move into the Borg scale and the rating of perceived exertion instead. All right, now into rating of perceived exertion. This is called the Borg scale. All right, this one is a little different than the previous two I've covered. This one actually is no longer a physiological test, it's actually a psychological skill. So this person is telling us how they feel, what percentage they think they are working at versus an actual heart rate number that we've been getting before. So the true Borg scale runs off of a 6 to 20. As you can imagine, this is our 60 resting beats per minute times 20 would be a 200 max heart rate. So that's kind of where these numbers come from, if that makes sense to you. Ultimately, the modified Borg scale, a little simpler to use, is just 0 to 10. 0 being so easy, I could do this all day long, I'm just basically sitting here, and 10 being so intense, I can't maintain this level. So this kind of gives us the modified and the actual rates that I had talked about, between 60 and 200 beats per minute. This is useful when comparing different activities, and it's actually very useful when heart rate can't be accurately figured out, okay? A lot of times with us, we're not standing on an elliptical machine that has a heart rate monitor on it. A lot of the workouts we do are more down and dirty. We're outside instead of being in the firehouse, we're actually out behind it, you know, putting gear on, dragging dummies, dragging rescue sleds, doing physical work that's more relative to what we would do on a fire ground. And this type of exertion scale is going to be a lot better because we can actually get their opinion on what they say and how they feel they're working. And a lot of times we can do it just by the conversations we have with these people. We're going to be able to use something called the talk test to be able to figure it out as well. All right, changing gears here a little bit, we're going to get into METs. A MET is a metabolic equivalent, easy for me to say, of multiple resting oxygen consumption, okay? So according to this, therefore, resting oxygen requirement is 3.5 milliliters of oxygen per kilogram of body weight per minute, okay? So to simplify this, ultimately what a MET is, it's just a way to describe the energy cost of work, okay? So if I am a person and I'm laying down, if I weighed 70 kilograms or 120 pounds, it would take me this amount of oxygen to just lay there on the couch doing nothing to survive, okay? That is one MET of energy. So ultimately what this is, it's just a way for scientists to quantify work, okay? So if it takes me one MET of energy just to lay there and relax on a couch or in a recliner, it may take 2 METs for me to actually get up off of the couch and walk down the hallway into the bathroom to use the restroom, okay? If that uses 2 METs, that basically tells me that is twice as strenuous as resting and doing nothing. So the big wow factor here is that firefighting activities have been shown, so when we're out working a fire, 11 to 13 times as strenuous as just laying at home relaxing. Okay, so ultimately with METs, this is kind of a changing gears, but this is just our way of showing the amount of work that's done over time. I'll go back to the whiteboard one more time with this. Ultimately, METs can be converted to VO2 max. We'll be using the calculation that I put on the board to show you these two things. Very simple. You've got your VO2 is equal to your number of METs times 3.5. It's pretty simple. I'll show you how to skew those numbers around. But ultimately, it's METs times 3.5 equals your VO2. All right, so With METs, to cover some of the calculations, spoiler alert, this will be on the exam at the end. So knowing this calculation makes it pretty easy to take the info that they give you on the test and actually relate it into the questions. So if they give us 15 METs, for instance, we basically plug that 15 in where the METs is, times 3.5, and that will give us what our VO2 max is. Okay, that's on the following slide, 52.5. Same thing, if they give us our VO2, I know in the equation they give on the next slide, the VO2 they give is 45, I believe. Yeah, so 45, and now they're asking you to give the number of METs to reach that VO2. It's pretty simple. You basically divide this whole side by 3.5, eliminates that. Divide this by 3.5, that will give you what your METs are. Little cross multiplication here post-college. So that will give you this, 45 divided by 3.5. The MET equivalent is 12.8. All right, so this simple formula, MET times 3.5 equals your VO2. That's one you may want to remember because it will definitely appear a couple times in your test. Now we'll move back into the ACSM recommendations. These are our rankings as far as our recommendations. We're going to want to have our people at 55 to 90% of the heart rate max, 40 to 85 of the HRR, 12 to 16 of our perceived exertion, and then 40 to 85% of the VO2 max. And ultimately, when we design a cardiovascular training program, intensity, all those numbers are easy and they're great tools to use. The easiest one for us to use on a daily basis is the talk test. Okay, if I'm outside behind the firehouse and I don't have access to all this equipment and I'm working out with someone and I'm having them flip tires and they're doing some things that are actually pretty strenuous, I can carry on a conversation with them and I can talk to them and I can try to figure out, okay, is this person at this level or are they actually pushing beyond the cardiac or the cardiovascular level? So the best way to tell when I'm talking to this person, can they carry on a conversation with me? If every other word is like this and they can't talk, that immediately tells me that they've pushed past that cardio level and they're actually into that anaerobic phase where they're having to burn, to make ATP, they're having to burn it anaerobically. Okay, so the goal with a good cardiovascular program, we want to kind of push that limit, but we want to keep them slightly lower so they can maintain that over the course of the workout. So that is my 15 minutes. I covered a couple key things, and hopefully I taught you a few things. That's it.